Hi everyone. The objective for this video is addressing old Regents questions relating to covalent bonding. Question 1. Which formula represents a substance that contains covalent bonds? Now remember, covalent bonds are nonmetals to nonmetals. So we look for nonmetal to nonmetal bonds and we try to identify the elements. So let's bring up our periodic table and take a look at metals and nonmetals. Let's also remind ourselves that the metals, let me grab a highlighter, the metals are all in this region. Okay, while the nonmetals, the reactive nonmetals, I should say, are right here, including hydrogen. All right. We do not include the noble gases because while they are not metals, they are non-reactive all at the same time. So let's inspect. Let's take a look at changing my pen here. Let's take a look at lithium and chlorine. Lithium is a metal right then and there, cannot be lithium. Calcium is a metal. It cannot be calcium. Potassium is a metal, cannot be potassium. And carbon and oxygen, here is carbon, here is oxygen. Both nonmetals, they will share electrons. It is a covalent bond. Choice 4. Number 2, which pair of atoms will share electrons when a bond is formed between them? Again, we're looking for nonmetal to nonmetal. So let's not only take out the periodic table, but zoom in on this section only. And we are looking for nonmetal to nonmetal. Barium and iodine. Iodine, a nonmetal. Barium, I don't see it. It is a metal. Bromine and chlorine. Well, here is bromine, circled in the big red circle. And here is chlorine. Those are both nonmetals. So the answer is 2, but inspect number 3 quickly. Potassium is a metal, as is lithium, so that would not be covalent bonds. But what type of bonds would hold these together? Potassium and lithium are both metals, while chlorine and iodine are nonmetals. If you remember, that is an ionic bond. Those two are. Now I'd like to continue by sharing with you this. We've done this in class. Why is it that fluorine right here, does share one electron with this other fluorine? And that's to satisfy that rule of 8, that octet rule. So we have 1, 2, 3, 4, 5, 6, 7 electrons from this fluorine, 7 electrons from this, and if they were to share one, it would behave as though they both had 8. So I put this circle around, this yellow circle around, and I count the valence electrons, the dots. And I do count 8. I circled this one, and it does have 8. Oxygen, when I put that circle around and I count the dots, I do show 8 electrons. When I circle this one, I show 8. Similarly, with the 2 chlorines, 8 electrons around each, and also with the nitrogens, believe it or not, there are 6 in the middle and then 2 on each side. So here's 6, 7, 8 for that nitrogen, 6, 7, 8 for that nitrogen. Number 3, which molecule will have a double covalent bond? A double covalent bond. Well, a single bond is a bond where the 2 nonmetals are sharing 2 electrons. A double bond, they must share 4. So I've already prepared the Lewis dot structures for each of these, and if we inspect them, let's do it this way. So choice 1 is fluorine, and what I see here is I see fluorine sharing only 2 electrons. That is a single bond. That could also be written like this, incidentally, with the dash representing 2 electrons being shared. Taking a look at number 2, oxygen. Oxygen here, in order to become stable, is sharing 4 electrons, which is a double bond, which could be written as this. So we already know our answer is 2. But inspecting the other choices, 3, chlorine bonded to another chlorine, it is sharing only 2 electrons, which can be written also as this. And choice 4, which is nitrogen, 2 nitrogens bonded together, and they're actually sharing 3 pairs, and that could also be written as this. And now this is considered a triple bond. This is a single bond, this is a double bond, and this too is a single bond. Number 4, which element forms a diatomic molecule containing a triple bond? Diatomic. Let me change the pen. Diatomic. Di means 2. Di is a prefix meaning 2. So diatomic, it has to have two atoms involved. So let's take a look at this illustration that I already put together right there. And what you see here is a diatomic element. Choice number 1 says a diatomic element, and it is sharing 2 electrons, which is a single bond. Chlorine, diatomic element, sharing only 2 electrons, a single bond. And here's nitrogen, diatomic element, sharing, well, I forgot a few dots here. Let me put them in. 1, 2, 3. They are sharing 6 electrons. So this looks like a great answer. Now, why didn't I map out number 4? Well, how many atoms are building this element? Or, I'm sorry, this element. It could also be called a molecule. How many atoms are building it? 3. That's not a diatomic. Diatomic means 2, while this has 3. So choice 4 wasn't even in consideration. Number 5, the degree of polarity of a chemical bond in a molecule of a compound can be predicted by determining the difference in. Well, let's look at a couple of buzzwords in here. And one I see is a chemical bond, I see polarity, and molecule. Molecule, you must think covalent bond, which means a non-metal bonded to a non-metal. So, which one of these is true? Melting points of elements. Melting point has nothing to do with polarity. Polarity is a difference in charge within a substance. Think of the positive and negative poles of a magnet, or positive and poles of the planet, and so forth. Density of elements in a compound, again, has nothing to do with charges or difference in charges. Electronegativities of bonded atoms in molecules of the compound. That sounds real good, and it will for a reason. I'll show you something in just a moment. But let's look at 4 atomic masses of the bonded atoms. Atomic masses just have to do with, in a sense, how heavy it is. Again, not to do with charge. So let's reflect on choice 3. Choice 3 says something about electronegativity, and in reflecting on that, electronegativity is an atom's affinity for acquiring more electrons. In other words, it is a pulling force. So if I have one nonmetal, and let's designate it nonmetal 1, chemically combined with nonmetal 2, and nonmetal 1 has a much greater electronegativity than nonmetal 2, there will be a pulling force on the shared electrons. The shared electrons will be more likely to be surrounding and orbiting the nucleus of nonmetal 1 than nonmetal 2. So they will be more frequently in the house of nonmetal 1 than nonmetal 2. And that provides this side here with a slight negative charge, while this side will get a slight positive charge. So the answer is 3. Question 6, which electron dot formula represents a non-polar molecule? So we're looking for symmetry here. We're taking into consideration the entire molecule, not just the individual bonds. Now, I was taught just recently by Dr. Spielman this acronym, and it goes like this: SNAP. Let's grab a pen. SNAP. Symmetrical is nonpolar. while asymmetrical is polar. So we want to find the nonpolar. So we are looking for the molecule that shows symmetry. Now, does number 1 show symmetry side to side? No. The chlorine and the hydrogen unbalance it, so it's not symmetrical. Choice 2, is it symmetrical top to bottom? Yes. Side to side? No, it is unbalanced. It is not 2. 3, is it symmetrical side to side? Yes. Up and down? Yes. It is choice 3, but let's confirm. Number 4, symmetrical side to side? No. Top to bottom? No. Again, confirming it is choice 3. It is non-polar. Number 7. The shape and bonding in a diatomic bromine molecule is best described as, again, diatomic meaning 2 atoms. Bromine molecule means they are covalently bonded. They are sharing electrons. Here is the picture. So which answer best describes it? Okay. Is it symmetrical? Yeah, it's symmetrical, side to side, up and down, symmetrical, but does that make it polar? Absolutely not. Not choice 1. Is it symmetrical? Yes. Let's ignore the second part just for a moment. Is it asymmetrical? No, and no. Can't be choice 3 and 4. Now, this is nonpolar because if you remember SNAP, as said just previously, okay, if it's symmetrical, it is nonpolar. So it is choice 2. Similarly, number 8. Which pair of characteristics describes the molecule illustrated below? Again, it's a molecule. They're sharing electrons. And if we closely inspect this one, there is no symmetry there. The distribution of charges will be uneven. In fact, oxygen, with its higher electronegativity, will have the electrons more frequent than the water, so it is slightly negative, while each hydrogen is slightly positive. So it is asymmetrical, which is 3 or 4. Being asymmetrical, SNAP, asymmetrical, polar. Choice number 3. Number 9, which characteristic is a property of a molecular substance, a covalently bonded substance? Are they good heat conductors? Good heat conductors? No. That is false. Are they good electrical conductors? Well, if they're not a good heat conductor, focus on conductor. If it's not a good heat conductor, it's not a good electrical conductor. Does it have a low melting point? Well, ionically bonded substances had high melting points, so covalent bonds have low melting points. So again, high melting point goes with ionic substances. And last, which formula represents a polar molecule? So I've drawn them out, the electron dot diagrams. Good idea if you were to pause this right now and look for yourself. Which one is polar? Alright, so if we were to inspect these ourselves, is the diatomic molecule bromine polar? No, it's nonpolar, it's symmetrical. Is carbon dioxide polar? It is 2, symmetrical. Is CH4 polar? It is symmetrical. Is ammonia, NH3, polar? Oh, I see asymmetry from from top to bottom. It is not symmetrical. There is an uneven distribution of charges. So again, SNAP. It is asymmetrical. It is polar. The answer is 4.